All right, let's get started. Welcome to the session on test driving code with the help of AI. My name is Venkat Subramaniam. Let's make sure the screens show my computer as well. So we're going to talk about using AI, but to write test cases. But this is about test driving, thank you, test driving the code. So before we get started with that, let's talk a little bit about this. To me, there are two main reasons to focus on writing automated tests. So the first one is the regression benefit. And the second one is going to be the design benefit. Now, when it comes to the regression benefit, so I'll be honest about it. I've been writing code for about 40 years. And for a very long time in my initial career, I didn't really do any automated testing. And I remember the time when I absolutely got hooked up on it. That was a summer day, right about June, actually, in 2003. So it's a little scary to think about nearly 23 years ago. But I've been practicing that a lot since then. But one of the things I often say is this. I write automated tests not because, I would emphasize, not because I have a lot of time. It is because I don't. So this is one of the reasons I focus on writing automated tests. And it's a huge time saver. How so? Well, typically what happens, your colleagues or your boss comes to you and says, we got to fix this bug, we got to make these enhancements, we got to add these features. And what do typically programmers do? They go make the changes to the code. But software is a nonlinear system. And once the code has been changed, we often ask the developer, how did it go? And they are usually like, that went well. And they ask, does it work? And what's the most favorite response we give? I hope, right? So we'd say, I hope. By the way, that I hope has a technical term. It is called JDD, in case you want to quote that to your bosses. That stands for Jesus-driven development. And we do this every single time in our work, right? We put faith into it. I hope it works. But I really want to focus here on TDD rather than JDD. So essentially, the idea is, how do I know this is actually working? But more important, as Ken Beck said, writing automated tests is more of an act of design than an act of verification. So I'm a huge fan of writing tests first before actually writing code. So what I find frustrating often is when developers want to write tests after, it usually becomes incredibly hard to write tests after. The reason is that your code has to be structured in a certain way for us to be able to write the test. So to me, it's a discipline. And once I have the discipline, I write tests and I write code. So I've been doing this for a few decades, like I said. So why am I really excited today if I've been doing it for a while? Well, what I really get excited about using AI is it actually takes care of things I find not very interesting. So let's be honest about it. I'm writing tests, then I'm writing minimum code to make the test to pass. But what do I do after I write a couple of initial tests? I want to write one more test with a slight variation. How do I do that? Well, I use this best technology called copy and paste. And I copy that, I paste it, then I start changing things over. That's not a good use of anybody's time. And if AI can do that for us, what a fantastic opportunity. So this is why I use AI for writing tests, not because I don't want to. It is because I want it to do parts I don't want to, so I can focus on the parts that I really care about. Well, what's a better way to look at it than to take an example? That's what we're going to do here today. So if it is so good that is writing tests, why are we not doing it? Like I said, it's a discipline. I often say that writing automated tests is the equivalent of exercising in the software industry. Most people, I would say, if I ask you, you don't have to raise your hand, but if I were to hypothetically ask you, raise your hand if you think exercising is good, I think most of us in the room will raise the hand. Exercising is good. But if I ask you to raise your hand, if you actually exercise, not many hands usually go up. Why? Because, oh, it's great, but not for me. Not for me, not today. I've got other things to do. And we come up with all these excuses. That's one of the problems we see often in the industry. Maybe will AI give us an opportunity to maybe become a little bit more disciplined because it can help us to write these. Let's just strive to take a look at it. So in order to benefit from this, I often say you have to be a really good, smart navigator. So I want to show you a few examples here as to how that actually leads into. And for this, I want to use a little example for us to work with. And I'm going to use a little game, Conway's Game of Life. If you know about Conway's Game of Life, it's a 0-player game. So you have cells, and the cells would be alive or dead. Now, the rules are extremely simple. Here's a very easy way to remember the rule. For a cell that is not alive, if you want it to come alive, it needs 3 live neighbors. Easy to remember. It needs a mom, it needs a dad, it needs a midwife. So if you have 3 things, it comes to life. If a cell is already alive, it stays alive if there are 2 or 3 neighbors. Less than 2, underpopulation, it gets bored, it dies out of boredom. More than 3, overpopulation, it doesn't get enough food, it dies. So that's basically the rule. But I want to build an example where the universe is infinite. It's easier to build this for a finite grid, and most people really approach it as a finite grid. But I really want to take an infinite universe and see how we can build it. So for that, the Wikipedia page contains a lot of really interesting examples, as you can see here. There's a block that is a bunch of immortal cells. Applying the rule, they always stay alive. Then there are oscillators that are going to really go back and forth. This is called a vertical and horizontal blinker that keeps going back and forth. And then there are these things that repeat a certain cycle over time, and the shapes kind of reoccur. So these are really good examples to look at if you ever want to look into. But what I want to really do here is to create a little example to see how we can actually do this. So I want to use AI, obviously. And I have this little code test I have started. Typically, I like to start with what's called a canary test. And a canary test is the stupidest test you will ever write. It simply asserts that true is true or it's a pass. So in this case, as you can see, when I run the test, you can see that it says the test is being executed, and the test did not record any output, it says. But it's essentially, this is going to be running this particular test, right? So this is going to be a canary test it's going to execute. And you can see in this particular case, it's going to run that particular test and tell us that it's passing or it's going to fail. So essentially, that's my very first test. As you can see, it says I'm passing. That's my first test. That's a canary test. Now, of course, I want to make sure it's actually working. So I'm going to set it to false and run this as well. And you can see that in this particular case, the test is actually going to fail. That's a good thing because you want to make sure it's really working, not fooling us. But I'm a lazy person. I'm not a big fan of, running things in the IDE. So I decided to just run this on the command line automatically. You can see the test is failing. So I'm going to go back and put this back to a pass right now. I'm going to go ahead and save that away. And you can see the test is passing. So I'm going to be just looking at it. OK, so we have the test passing. But I want to start by really looking at how to design code with this. There are a few tenets I follow, but I'll come back to that in just a few minutes. So to me, the first thing I want to emphasize here is that design, I often say, is incremental. So I incrementally design my code. And I would say, and it is a process of discovery. So let me emphasize this really quickly. When people say do TDD and write test, write code, write test, write code, I often say I have no clue what you're talking about. So to me, it's write test and stare at it and complain and cry and examine it and rework your test a few times and then write the code after it. Because I use a test to drive my design, so it's not a mechanical process for me at all. So I invest a lot more time in my test than in my code. This becomes even more important today with AI because if you have really solid test cases, you can have AI generate the code any number of times as long as those behaviors are well kept. On that regard, I would say, well, let's actually say that after we look at an example. So we are using AI here. So I'm going to say test, and what does it do? It says test 2. Well, that's the very first thing I want to emphasize. So AI has no clue. It has the starting problem. It is not smart enough to know what you're doing. So it just simply says, I'll give you a test over here. And what does the test actually say? It's a test 2 and a pass. What is the use of this? You know it's useless, but the tool doesn't know that, right? So I'm going to say, yeah, good try, but that's kind of useless. So I'm going to say test a game of life. And the minute I write it, it says, create a game of life and check it is not null. One of the things when I coach my team on test-driven development, I always tell them, never write a test to check it's not null, because that's absolutely useless. But why does AI write that? It's because a lot of people write useless tests. It's learned from useless code. That is one thing we need to be careful about. It's not producing things because it's right. It's producing things because it's seen it. And if you're in my previous talk, I mentioned that AI is an accelerated inference. So it comes to you and says, I saw 1 million people do this, so that's got to be good. But it's not, unfortunately. So this is a useless test, if you will. So then I say, nah, that's not what I want to do. So game of life, and if I were to kind of tempt it towards that, what does it actually create in this particular case, right? So there's no point in checking for null. Again, this is kind of non-deterministic. It's even worse. Is it an instance of game of life? What else can it be, right? So if you're bent on writing stupid tests, it's good at writing more stupid tests, as you can see. That doesn't help at all. But even worse, if we were to go back and say, let's say test, let's say a game of life logic. I'm going to just start with that really quickly. And the minute I do this, it says you can initialize the board, you can act and assert. Well, guess what? It's learned this thing called arrange, act, and assert, which is a nice way to write test. But I often tell my developers, use arrange, act, and assert, but don't put that stupid comment to say you're using act, arrange, and assert. So you can again see somebody has done that, so it wants to do that as well. It's going to see that. Again, this is a bit unpredictable what it's going to create because it's not very consistent. But in this case, I'm going to then say, public, let's say, void, test, let's say, a game of life. Let's say, in this case, alive. Let's say dead, cell. And the minute you say it, notice what it says. I want to create a game of life. I want to create a board. I want to create a next state, and I want to do this. You can see the tendency here is to jump ahead and do a lot, again, because that's what it's really inferring from. People often do that. Now, one of the tenets I follow in design is, this is something I emphasize, design, as much as possible, right? Design, I would say, design stateless as much as possible. So essentially, I don't want to bring state unless I cannot live without a state. So at this point, you can see AI has a starting problem. So I'm going to ignore it and say, you know what, you don't have a clue where you're heading. So dead cell, I'm going to say behavior. And then I'm going to simply, in this case, and you can see when you're using AI, for every few lines you type, immediately it wants to rush and write some more code. I call this programming with the in-laws, if you know what I'm talking about, right? You get interrupted when you're trying to do stuff. At some point, I just say, turn it off, let me do some work, and then turn it back on after that. But in this case, I'm going to ignore it and say assert, and I'm going to say that. And in here, I'm going to say, this is going to be a game of life, I'm going to say, dot, next state, and the current state is dead, and the number of live neighbors is 0, and I'm going to then say, comma is equal to dead, so that part is actually good, if you will. And I'm going to say close it with that, and let's give it a try. So that's my very first test I'm writing, and kind of instructing it the direction where I want it to go. Well, what is this game of life? Well, the game of life is going to be, of course, using a game of life library. I'm going to bring the game of life from there. And on that game of life, I want to write a next state function right in there. So I will say this is going to be a public. This is going to be a cell state, if you will. And this is going to be the next state, which takes a cell state, which is the current state, as you can see. And this is going to be, we'll call it int, we'll call it as number of live neighbors, right? So again, it's eager to write a lot of code, but in the spirit of test-driven development, I'm going to remove all of that and simply say, hey, return dead from this. That's good enough for my purpose right now. So what in the world is dead? So I can go back here into this code, and I'm going to say right there, I'm going to create a game of life. We'll create a cell state. So I'm going to say this is going to be my cell state that I want to write. And the cell state.cs simply says this is going to be a namespace is going to be the game of life library. And I'm going to say public enum cell state, and that's going to be a dead and alive as the states. You could say put dead, don't put alive yet. That's perfectly fine as well. So we create that right there for the state at the moment. So now that we created that, we can then go back here to this particular code and say, hey, I want to really bring in that game of life in here, which is going to be from this library, game of life. So we can go back here and say, hey, I want to take this game of life test. Let's go ahead and bring in the reference, in this case, add project reference. This is going to be the game of a life library. We bring that in, and that's going to be the reference we are going to be bringing in, and that's where the game of life is going to come from. Then what is the dead? Well, the dead is going to be, of course, in this case, using, let's say, static. This is going to be a cell state that we are bringing. That's where the dead is going to come from as well. So that's basically what we brought in right now in the game of life and cell state that we brought in. So that's our very first test that we are bringing in for us to use. Let's see why this is not resolving just yet. So this is going to be the game of life. Let's say game of life should be the one that it brings in. Okay, looks like it's happy, well. Oh, I want to make it a static method, right? I'm sleeping at the wheel. So let's go ahead and say public static. That's basically what we are interested in, and that should really bring in the method at this point. All right, so it should have brought in, but we'll see why. Okay, now we have one test that we have written right now, but what should I do? I need more behavior here, obviously, for this. So if I hit the return, you can see that it's adding a few more things right there. And don't assume it's all correct just yet, but let's go with this for a minute. And I'm going to take all of this except this one for a second. So if the number of cells is 0, 1, 2, or 4, if the input is dead, the output is dead as well. But let's just pause here for a minute and think about what just happened. So one of the tenets I follow is when it writing test quality, about quality of the test, I would say never put multiple independent, I would say, asserts in one test. Now, this is one of the things. Why not? Because if you put multiple independent asserts in one test, if one of the asserts were to fail, the remaining asserts will not run anymore, which means you're not giving full visibility to the impact of the change. So you should never put multiple independent asserts in a single test. Again, that's a tenet that you follow, but a lot of people don't, and AI doesn't know that's not a good practice. You can write skill files to provide those kinds of recommendations, so AI doesn't go off and do those things. So in this case, I'm going to say an assert dot multiple, and then within the multiple, I'm going to go ahead and add that one right there and ask it to execute it. So what does multiple do for us? Well, multiple actually executes each one of those test cases. So even if one were to fail, the remaining will run as well. So that gives us the feedback about the real impact of the change that can be very helpful, if you will. So essentially, in this case, the name dead does not exist in this context. It says that's in game of life 16. That's because I've got to go back and add this here as well. So let's go ahead and say using static cell state, and that should bring in the dead right in here. OK, so we brought in those things. And then, of course, back here, we have those classes. Let's see what it complains right now. So it's still not seeing it. What was that? So you restored faith in pair programming for me. Thank you. As you can see, I can talk or I can type. I cannot do both, but I still try it. So this is a dead as this and then cell state. So that's basically the case difference. And here you are saying this one has a case difference. That's because this game of life has a typo that should be game of life. Good job. Awesome. Thank you. Now you see why it's not catching it, right? Great. So now that we have that in place, what is the next step? We put the multiple, and then we wrote this test to verify this behavior. And as a result, in this case, let's go back and verify this is correct as well. So this is going to be a dead as that case, one more difference. And go back here, and that is our test case. Yay, that's actually passing. So we wrote our very first test, and we used a little bit of a variation using the multiple. Where does this take us? I am going to then say, assert, did you notice it was pretty good now? It learned from me just now, right? This is instantaneous learning. It said, oh, you wrote the dead cell behavior. Let me write an alive cell behavior for you. It also very nicely wrote the multiple also, as you can see right there, because it realized, aha, I know where you're going, Venkat. I'll follow what you are saying. And that's the part I actually like. It may not know where you want to go, but it catches on very quickly. In that regard, it's kind of like walking your puppy, in the evening. It wants to go straight, but you give a little tug to know that you're going left, it knows to turn and go with you, right? So it kind of figures out when you do that. So I'm going to go back here and say, for the dead cell, it's going to be alive, as you can see right there. And for this one, all of these are alive, but these are going to be alive as well. It's kind of funny how that commented out those two parts, as you can see, right? It literally is following what you have previously. This test is going to fail, obviously, because we haven't implemented the code yet, but that's a good opportunity for us to implement. So it uses a switch to implement. If you're a fan of switch, keep it. Great. I have no problem with it. Or I can say, if the number of live neighbors is equal to maybe a 3, or the current state is alive, and the number of neighbors is 2, then return alive, otherwise return dead. And I can write that code using a ternary operator. And of course, there are only two kinds of people, right? Those who love ternary and those who hate it. So, but the good news is you can write the code any way you like, and you can implement it at that particular point. You can see the tests are passing with that implementation. So that is done. Now what are we going to do? I'm going to go back here and say, here is my next test. And now what does it say? I want to write an edge case, it says. But do you really need an edge case? This is kind of meaningless. When will the number of cells be negative? So this is one of the things to keep in mind. Tests are sampling of input, but those have to be sensible. They have to be meaningful. So there is no reason really to write a -1 and an 8. So I would say, no reason to go write that. So what is the concern here? So the concern here is that when it comes to AI, it has a starting problem. That's the first thing we talked about. You can also say that it has a turning problem. So it may not really know when to say, I am done and I need to pivot in a different direction. It may not really know what that pivoting direction is at the right time. You may have to help with it. So in this case, I'm going to say, there is no point in writing it. So what is the next step I'm going to do? Let's pause for a minute and think about it. So in this case, we are driving a design. So I can think about this and say, I really want an infinite universe. So as a result, a grid-based design will not help. So it didn't do this today, but a lot of times what it would do is it would start really creating a game of life object. It would call setters on it and put some values into it, call getters. And usually I try to avoid sets and gets generally. I want to really move towards behavior testing rather than putting state and testing state. Just like I said, it's behaving better right now in front of you, but it behaves very differently when I'm alone with it, right? So essentially, when it does that, kind of deviate from there. So what is the test I want to write? Well, a realization after a lot of pondering I would come to is, one way to implement an infinite universe, obviously we cannot really implement an infinite universe, is to really keep only the live cells. Well, why would that help? Because life is sparse in the universe. The universe is really, really big and it's infinite, but the number of lives are really finite and sparse, so maybe we'll just keep the live cells. So looking at that idea, what I would do here is to say, test, generate signals for one cell, and I can write this test as generate signals for one cell. But this is where you can minimize quite a bit of your effort. For one cell underscore, let's say 2 and 1, like so. So notice when you say 2 and 1, you are giving enough information for it to be able to code those values in. Well, what is it doing? What it created is not good enough. I'm going to delete it and say assert, in this case, that, and I will then say game of life, and we'll call this as generate, we'll say signals for one cell. And notice it's able to fill in 2 and 1 based on the description I gave up there. And it says equal to. So is equal, let's say is equal to. But what is it equal to? Well, in this case, I want to say it is equal to a new list. And the minute I type it, it catches on to where I'm going. So initially, it couldn't do what I wanted. But the minute I start typing, it is like, oh, so that's where you're going. It immediately catches up. But here is something else I really like. Did you notice it was really good not only in putting the cells, but it also visualized the positions of the cell really nicely. You say, oh my gosh, that's pretty smart. No, it's not smart. Somebody has been smart. And I have written like that before. Others have written like that as well. And it literally copied that over to say, look what I can do. So the smartness is not in AI. The smartness in the people who wrote that code originally. And then, of course, AI just brings it over. You can say AI inferred the code. In a blunt word, it copied that code, right? As I mentioned in my previous talk, at the university, we call it plagiarism. When you try to copy somebody's work and don't give credit, that can get you into trouble. With AI, it gives you credit, right? So that's a sad part of life we live in right now. But be careful. One of the things I've seen VS Code do quite often with Copilot is it would generate this and then give you a warning to say, hey, I got a source from which I derived it in case you want to look at. So that way, if you feel a legal trouble that could be pending, you may want to be careful about it. So I would say use caution when you bring code like that, just to be sure it's legitimate. So we wrote that little test that's going to fail, obviously, because the function doesn't exist right now. So you can see that's going to fail as you would expect. But what are we going to do with that particular code in here, if you will? So in this particular case, we want to be able to write this generate signals for a cell. What is it going to return back? A list of cells, right? And in this case, we're using tuples for this list. That's what we are doing. So we can say public, in this case, a static, a list of int, generates cells for, and it takes a x and a y as a cell, but you can change that to return a tuple here as well, because it's, after all, a cell. Why send two different arguments in this particular case? So then you can go back to the code right here, and you can say this is going to be a tuple that I want to bring in. And in this case, it's going to be a tuple of an int and a int, which is going to be the cell. And it then says, I'm going to get you an x and a y, and return those values. And again, look at the visual, nicely laying out based on how it is topology, how the topology is. I think that's a pretty good job done by this particular generation right there. So that is our test right there. And you can see that test is passing. So that's pretty darn good. Now, remember what I normally do. When I finish writing this, I want to write one more case. But for that, I typically copy and paste it. Well, the good news is I don't have to do that, because it is able to generate based on what I created. It said, ooh, you created a 2 and a 1. Let me create a 0 and a 0. So in this case, I'm going to just accept what it created, but verify it is actually correct. Don't assume it is. For a 0, 0, it's a -1. It's a 0 over here, and it's a 1. And you can verify if that seems to be correct. And if it seems to be correct, you can simply accept it and verify the test is passing. So we wrote two tests. And what are we going to do next in this case? Well, it says for 1 and 1. Well, that brings up the next point. It's got also a stopping problem. It is not smart enough to know you've covered enough test cases to write. If you were to just keep hitting tab, you're going to be sitting there for a very long time writing more and more tests. This is a sign when people have more tests than necessary, they were not paying attention to what they were creating. So don't let it just keep creating test cases when the test is no longer beneficial. Divert it to a different direction. So what am I going to say here? I'm going to say a public void test generate, in this case, signals for cells where the list is empty. So I'm going to say create this for cells where the list is empty. Well, again, it doesn't know quite what you're doing, but assert that generate signals for, in this case, I'm going to say cells. And what is the input you're going to provide? It's going to be a new list that's empty. Again, it catches on pretty quickly, right? So when I said for cells, it immediately filled in the empty cells for you. And then I'm going to say is, and what is this going to be? Is equals to an empty cell. So the moral of the story here is this. It may not get it right, but the minute you start typing, it catches on pretty quickly. So you don't have to spell everything to it. You just change a direction, and it leaps forward and says, that's where you wanted to go. And it may not be right, but usually it seems to be heading in the right direction. So I'm going to write this get signals for cells. So what are we going to do to write it? So I'm going to go here and say public static. The result is a list, as you can see. Generate signals for cells, and it wrote that code, as you can see. Let's pause for a minute. There's nothing wrong with the code it created. But this is just my choice. Maybe you are like that. Maybe you're not. It doesn't matter. I respect any way of writing code. My preference in the past several years has been more of a functional style of writing the code. So I might really say, yeah, I don't want to really do this. I probably want to really use a functional style. The good thing here is it was able to build this function using the previous function. So that's a good news. But I'm going to pause here for a minute. I'm not trying to put you on the spot, but I just want to entertain a thought. If I were to write this in a functional style, what functional operation you think is going to play a role? I heard a select. Can you complete it? It's more than select. Select many. It's a flat map problem. Bingo. Right? It's a flat map problem. So you're right. It's a select many. So it's a flat map problem, but here's the cool thing. I can say implement using functional style, right? And notice it is able to understand where I want to go. So it says live cells.selectMany.toList. That's pretty darn cool, isn't it? So if you were to guide it, so what does that really tell you? I have this philosophy as of now. So it is, I'm going to say, it is as good as you are. And that is the problem, right? If I am really good at writing tests, it's going to be as good. And to more emphasize it, with AI, the world is turned around. With AI, smart become smarter, and sadly, dumb become dumber. So essentially, if you have somebody who has no clue how to write good unit tests, and you tell them, go write unit tests with AI, sorry, good luck, right? But if you have somebody on your team who is good at writing unit tests, you tell them, go use AI to write unit tests, you're in good hands, because they're going to be much more faster in getting things done, because the things they had to do manually now can be automated, but while they can still use their skill to direct where AI need to go. The reason I want to emphasize this is, if you work in an organization where your bosses think that we don't need people to know stuff anymore because AI can take care of, my recommendation is, when you hear that, I sincerely tell you, don't walk away when you hear it. Run. Because you want to be as far away from the blast radius as you can. Because when they start putting this in the hands of people who don't have a clue, you don't have a clue what it's going to create. That's the real emphasis, right? So this is a good tool in the hands of the people who are knowing what they do. Not a substitute for knowledge and foundation, but it really enhances what you have already. That is the key. So in this particular case, we asked it to generate it, and I'm going to look at it. It says game of life does not define that particular function. Let's see what's going on. This is going to be generate signals for cells. That's what we are calling it. So signals for cells, that's the name we are providing for the function that we are using, and now the test is passing. Well, now that we wrote that, what do we want to do? We obviously need a few more tests for this. So what's our next test? So we can then say in this case, for the next test that we want in here, let's go back here. So for the next test, I'm going to say generate for one cell, it says. And I'm going to say, hey, that's pretty darn good. For the cell 2-1, it's generating that. I like it. Verify it's a good test. And then make sure it is actually passing as well. Got it? Nice work. What's the next test I'm going to create? For 2 cells, I'm like, good job. And you got 2 cells, 2-1 and 0-0. And it's nicely lays it out as well. Makes me happy when I see that. And verify it's good. And the test is passing also. Well, what's the next test after this? Well, the next test I'm going to write after this one, it says, write this for a cell where the list has 2 cells with duplicates. I think it really got a hang of where I'm going with this, right? But I'm going to fine-tune this just a little bit. So I'm going to say with the duplicates, but notice 2-1, 0-0, 2-1. This is just me. I'm going to say with one duplicate, right? With one duplicate. And I'm going to say this is going to be the duplicate I'm interested in. And what did it create? 2-1, 0-0, and 2-1. And it creates that, and it generates that. But actually, you know what, I would argue that doesn't make any sense to have duplicates in this case, because these are live cells, right? So, I just got carried away. It was not a good test. So be mindful, right? Don't assume what it's doing is really good. Again, remember, it has a stopping problem. We wrote enough tests. That's more than enough for this purpose, I would argue. So no point spending more time. Where do I go with this design again? Again, this is the skill you already have or should have or gain as to how to really incrementally evolve your design with your test cases. Well, where I want to go with this is, I want to say that a public, let's say, void, and remember, it has the turning problem. So I'm going to say test count signals where or I say for empty signals list, right? So I want to give an empty signals list and ask you to count the signals. Now, again, don't trust the code it's generating at this point. So I'm going to go back to this and say, nah, not what I want. So assert that. And what do I want to assert right now? That in this case, game of life dot count signals. And here is my empty list of signal that I want to provide to it, right? That's what I want to bring in. And then I'm going to say, comma, is equal to a dictionary that is empty, right? So you can see how it was able to nicely bring about that empty list, as you can see right there, that we are providing, and it's going to bring in the dictionary which is empty, right? So that's a direction I really want to take it. So right there is the empty list, and you are saying for that empty list that I'm passing, so count signals, let me go through this, and there's the empty list I'm going to pass to it. I don't need this one, that's a function, and is empty dictionary, that's what I really want. So what is the count signals going to do right now? So I'm going to say this is going to be a public, let's say, static. This is going to be a dictionary, which is an empty right now. And it's going to be count signals for those signals. And again, you can see it really wants to rush through. And I'm going to say, don't go there. Return new and an empty dictionary that doesn't have anything is good enough for now. So we'll again take baby steps towards it, right? So why do I really bother about these small tests to begin with? So this is a philosophy I follow again in terms of design. So essentially, the way I design code often is the first few tests help me to tease out the skin of my functions or methods, and the following tests, I would say, help me to bring in the guts of the methods. So this is a philosophy I follow when I write test cases. So the few first test cases I write helps me to design the skin of my method. In other words, I want to tease out the interface of a method. Once I have an interface that I'm comfortable with, then I want to write test cases to bring in the implementation. And that's one of the reasons why my initial test cases really focus on the minimalism and what I want the function to look like more than what do I want to have as an implementation. So in this case, I just asked it to implement for an empty signal. That's all I did. But now that we did that, let's look at what it's going to do next. So it says where you have one signal. I'm going to say, yay, that's great. And what does it do? Here's a one signal, and the dictionary contains one element. And you can see once again, it caught on very quickly where I am taking it, right? So this is a pattern I notice over and over. It doesn't know where to go, but it's very good in leaping forward once it knows where you are going, right? So in that regard, that's why I gave the analogy like having a puppy that you're walking. It may not know where to go, but it's very happy to jump in forward and move ahead once you set the direction where you want to go. So I'm going to write the next test right here. And I'm going to say this is for multiple signals. Well, that's great, but I want to refine this a little bit. So test count signals for, I'm going to say signals, and I'm going to say 2, 1, and I'm going to say and, let's say 4, 7. So the beauty of this is when you type those words, it's able to figure out what you are asking, and it implements those for you quite easily. Again, verify it's actually correct. and ensure the test is passing. Ooh, in this case, it's not passing. Let's see what's going on. Well, you know why? Because we have not implemented the code just yet. So before we implement the code, does anyone want to take a guess? What function, again, as you know, I'm a fan of functional style of programming. What function would you be using to generate this dictionary? Any clue? You got many signals, but you want to count the number of times a signal appears in that list, please. Distinct will give you only unique values, but here we want to count the number of occurrences. Good try, though. That's how we keep thinking and getting better, so I appreciate your response. Please. Group by, absolutely. So group by will do the job for you. So in this case, it still wanted to write it in imperative style, as you can see. Oh, a quick question. Why do you think it's writing in imperative style? Because that's what most people did, right? So that is one thing we need to really keep in mind. AI is not doing what's smart. AI is doing what is popular. It has seen more of that. It wants to do more of that, right? So write this in functional style. But in all fairness, I could have written a skills file. So my skills file often contains several of these directives. Where possible, write functional style code. Where possible, avoid mutability. Where possible, be stateless instead of being stateful. Where possible, focus on writing code that is expressive than terse. I give all these directives in my skill file. And when I do that, it tends to favor that more in general. So write this in functional style, I'm saying. And what did it do? In this case, group by, as you rightly pointed out, it's able to write that right there. And then, of course, it's returning that particular dictionary, as you can see, and the test is passing. So one more, right? We know better. It may not know, but you know. So now it says public void, right? The next one, public void test signals for, and I'm going to say, count signals for 3 signals, I'm going to say, with 1 duplicate. So notice, I'm just directing it as to what to do, and what did it do? Now it's got a duplicate, as you can see. So it's pretty good when you express in words your intent. Honestly, when I didn't have AI, guess who is going to be typing all of that, right? Me sitting there, and as you probably guess, I'm not good at typing those things. You already gave your evidence in the beginning. I couldn't even get the case properly, right? So I'm going to be struggling with that because my mind is not wired that way, because I'm creative, but I'm not really capable of being correct oftentimes. So, but when I type those things, it leaps forward to implement it. That's a huge saving for me in terms of my time. And verify again. 2, 1 is 2, and 4, 7 is 1. And it's able to bring that in together for you. Okay, now I'm going to say test one more time. What does it do? It says with the 2 duplicates. But guess what? It doesn't add any value. So the key here is that when, right, so the goal is not to write more tests. So that is something we need to keep in mind. So this is where you have to kind of hold the leash and say, that's enough. Let's go this direction. No need to keep doing more in that direction. So you have to redirect it quite often. So as a result in here, I'm going to say public void test, and I'm going to say next generation, right? The next generation for, I'm going to say empty live cells list. I think it caught on fairly nicely right there. So you can see this is why it's an inference engine. And suddenly it says something completely absurd, right? And my only request to you is be kind to it, right? In my previous talk, I was telling you that don't use the word he or a she. It's a it. So my request to people is this. Don't treat it as something sacred. Don't call it he or she. But also, don't treat it like Malfoy treats Dobby in Harry Potter, right? So be kind, because it's not kindness to AI, it's a kindness and respect to yourself. So when it does stupid things, you just say, yeah, I know you're just a tool, I'm not going to get angry at you. Because most of the time you're good to me, so this time you said something stupid, I'll just ignore it, right? So basically, assert pass, you just get a little, I mean, it's trying to be funny to you, maybe, that's what it is, right? In its own way. So yeah, no thank you. So assert that, and next generation, again, the minute you start typing, it leaps forward, right? So next generation, here's an empty list, and the result is an empty list as well. That's pretty darn good. So we want to implement that function right there that we are implementing. So right there is the function. Next generation, it says list, which is kind of silly. So this is live cells, and the result of that is not a Boolean. That's silly as well. So you can delete it if it immediately writes the right version, and it says not implemented. I'm going to say, yes, I want to implement it, return new, and I'll return an empty list for now. I'm not going to do any more work than that at this particular time. So we are almost to the end of that. So let's go back and make sure the test is passing. It is passing, as you can see. So now we can say, here is my next test. And this says, for one cell, hey, that's pretty darn good. That one cell, you know what the result of one cell is going to be? That one cell has no neighbors, so the result is an empty universe at the end of this, right? So that's basically what you're going to get at the end of this. So let's go ahead and ask it to move forward, and let's go ahead and take a look at what it created. And you can see in this case, that test is going to be passing as well. The next one here, I'm going to say test, and public, let's say void test for 2 cells. Hey, that's great, thank you. That's going to be, again, you can verify it's an empty list, and the test better be passing as well. You can see the test is passing. And let's go ahead and write a couple of more tests. And I say public void for 3 cells. Yep, go for it. And that's going to be an empty cell as well. Nice work. And then, of course, make sure that test is correct and the test is passing. Maybe 2 more tests. Here's maybe 3 more tests. So it's going to be for 4 cells. But the 4 cells can be arranged differently rather than being empty. That's not very useful. So I'm going to back out of it and say, no, why not create a next generation for, maybe we can say a block, right? So I say for a block. And the minute I say for a block, it creates a block, as you can see. And we saw this on the wiki page. And the block is a set of immortal cells. And you can see it comes back with exactly the same. Let's see if the test is passing. No, you know why the test is not passing? Because our code is not implemented. So at this time, we can implement the code. And once again, it falls back to functional style. Again, have a skill file. You don't have to repeat this. And let's write it in functional style. And it says generate signals. Generate the signal for that. And then what does it do? Right there, it says where and select and implements it, as you can see. So that's basically the implementation that it brings together. Let's see what's going on here. So this is basically saying for the next state, I'm going to go ahead and say contains the live cell. If it is alive, and do a select on it and get the keys and do a list. And it's going to return the list for all these live cells. Let's make sure this is actually correct. Is this block actually correct? Let's take a look at it. So 1, 1, 1, 2, 2, 1, and 2, 2. So that is 1, 1, 1, 2, and 2, 1, and 2, 2. But let's take a look at the error. So the error here says that the generation is 210011, which is what it says. assert that given that particular list of cells is equal to a list of empty. Well, for this, there are 3 cells, and is the result empty? So you need to verify that the test is actually correct. What was it doing before? Think about it for a minute. What it was doing is, that's why we have to, when it writes a test, you have to examine if the test is correct. What it was doing was it wrote the test, looked at the implementation, and the implementation was returning empty, so it put an empty for you. You got to be very vigilant about it and make sure that it's actually correct, otherwise it's going to be a problem. You can see what's going on with that, right? So you have to be really careful to verify the tests are actually correct, otherwise we're going to be in trouble eventually. Anyway, so with that said, we can write a few more tests in this case. What can we do? Notice we can say, write this for, let's say, a vertical blinker. And then you can also ask it to write a test for, in this case, as you can see, a horizontal blinker as well, and so on. So essentially, what we have seen here is that we can write the test cases with AI. If you are doing test first development, the essence here is that it's not going to know exactly where you're going, but in all fairness, you shouldn't know where you're exactly going either, because you're discovering your design along the way. So a few things to wrap up our discussion. We saw creating the test cases with AI. We started with a canary test. Generally, I'm a fan of writing the canary test. Canary test helps me to warm up, make sure my environment is set up properly. When I'm new to a project, if I see some failures, if the canary fails, I don't have to look any further. It's usually a configuration problem, nothing to do with my application. So it's a nice way to warm up, so I normally start with a canary test. We looked at the very first test it created. It was not really any good at all. So that's one of the things to keep in mind. If you don't know how to write test cases, you're going to go with it, which is not going to help you a whole lot. But if you know how to write test cases, if you're an opinionated designer, then you're not going to take what it provides. You're going to immediately direct it to where you want to go. So you have to be a very active navigator. You have to be very vigilant about it and constantly say, go this direction, don't go there, and redirect it to where you want to go. But the good news is, the minute you give it a tug, it knows to go in the right direction, so you don't have to repeat it many times. It follows very quickly. So a few things to observe. For using AI, it is something that matches the your intelligence, right? So that is the key here. So it's not actually, maybe you can call AI as, hey, I think we found the definition of AI, finally, right? Sorry it took me this long. AI is not artificial intelligence. I just realized it just now in this talk. Let's put it as discovered in Copenhagen, right? So it's not artificial intelligence. So what is it then? I'm going to say it is amplified intelligence. That's what it really is. So it really amplifies your intelligence. If you are intelligent, it amplifies it. If you're not, there's still time to become intelligent. So essentially, that is what AI is. It's amplified intelligence. That's what I realized eventually, right? So it really is as good as we can be with it. So it reflects our capabilities quite a bit, and that's the power it has. So to me, as an experienced programmer who does test-driven development, I love AI. And the reason I love AI is not because it replaces what I do, it's because it amplifies what I do. It minimizes my manual effort. It minimizes my copying and pasting. It minimizes my redundant work. Instead, it allows me to focus on what I truly enjoy, which is designing my software, and it takes away the mundane aspect of it, which is not what I really enjoy the most, not where my time is well spent as well. Hope that was useful. Thank you.